All right, today we are doing lesson 28 on scientific notation. The definition of scientific notation is a method of writing a number as a decimal and a power of 10. Here's an example for you. 3.0 times 10 to the 8th. 10 to the 8th is called your multiplier. 3.0 is called your coefficient. When you are writing numbers in scientific notation, you need to make sure that there is only one non-zero digit to the left of the decimal point. You can have as many places as you need to the right of the decimal point. If it is a whole number, standard form tells you to put a 0 in the tenths place. That would not be considered an extraneous 0. So what does scientific notation tell us to do? This basically tells us that we are going to multiply 3 times 10 to the 8th power. 10 to the 8th power equals 100 million. So we need to shift our decimal point 8 places to the right. It is good to physically show this. 1, 2, 3, 4, 5, 6, 7, 8. Fill in all of your loopies with zeros, rewrite the number, and insert your commas, and you have 300 million. Scientists use scientific notation because this many zeros in a textbook would become cumbersome, and most scientists understand the powers of 10. And powers of 10 indicate place value. For instance, 10 to the 6th is written as a 1 with 6 zeros, or 1 million. 10 to the 3rd is 1,000, a 1 with 10 zeros. So what would 10 to the 0 be? Well, it says put down a 1, but do not put down any zeros. So 10 to the 0 actually equals 1. We have the number 93 million here, and you want to write it in scientific notation. What do? You start at your decimal point, and you move and count your places as you're moving to the left until you get your decimal point to where there is one non-zero digit to the left of it. You then copy down that digit, the decimal point, and any non-zero digits after the decimal point, and count how many places you moved your decimal point. In this case, you moved it 3, 6, 7. So your answer is 9.3 times 10 to the 7th. You can check your answers by then writing it out and say, I need to move my decimal point 7 places, and 1, 2, 3, 4, 5, 6, 7. Put your commas in and make sure you have what you started with. If you have a number in scientific notation and they want you to write it in standard form, which means writing it with all of your zeros and no powers of 10, this says move your decimal point 6 places to the right. 6 is a positive exponent, so positive numbers move to the right. Copy down your coefficient, move 6 places. Fill in your loopies with zeros, rewrite your number, and put in, oh, I made a mistake there. Count 3 places and put in your comma, and you have 1,600,000. Scientific calculators indicate powers of 10. So if you put 1 trillion into your calculator, and it would be good for you to do this, you might see 1 point with a 12 in the air on the display board of your calculator, and that means a 1 with 12 zeros. Or you might see 1 times 10 to the 12th actually on your display board. So it's a good idea to play around with your calculator and see how they're displaying it. But that's what these numbers up in the air are powers of 10, are indicating powers of 10. So suppose you had this problem, you had to multiply 300 million times 31,500,000. That'd be a lot of zeros to write down on your paper. So you might say to yourself, it might be easier to change this to scientific notation. So let's do that. We need to move our decimal point to where there is one non-zero digit to the left of the decimal point. So that would make it 3.0. How many places did we move our decimal point? 3, 6, 7, 8. So 3.0 times 10 to the 8th. Here, we need to move our decimal point from there in between the 3 and the 1. So we have 3.15 because we copy down every non-zero digit after the decimal point. But we still moved 3, 6, 7 places. So we now have 3.0 times 10 to the 8th times 3.15 times 10 to the 7th. You can rearrange all of these factors because of the commutative property of multiplication, and we're going to rearrange these to say 3.0 times 3.15 times 10 to the 8th times 10 to the 7th. 3.15 times 3 is actually pretty easy to do in your head. It would be 9.45. And if you can remember back to last lesson where we talked about the law of exponents, if you have the same base and you are multiplying two numbers, you can just add the exponents. So 10 to the 8th times 10 to the 7th is 10 to the 15th. So you've made a hard problem pretty easy. And so today you are going to work on problems A through J on page 183. Please read through the lesson to make sure that you really understand scientific notation and come up with any questions you might have that are a little bit confusing to you, just to make sure that you know which way to move your decimal point when you're going from standard notation to scientific or scientific notation back to standard. Good luck.